a different setup, and maybe this will work. This talk, the past month or so, I've been working with MyPy, which is a Python type checker. It's something that I've just never looked at before, even though it's been around for about 5 years. And I learned a ton, and like, I'm not giving this talk because I have the right take on MyPy, but I just can't stop talking about it and thinking about it. So I figured, let's talk, and I want to hear your opinions too. So originally, I had a bunch of slides in this talk that were like, part 1, what is a type, and like, what is a type in Python, and what is a type in Java, and that was really boring. So I'm just going to jump in and show you some stuff. So if you decide to use MyPy, a lot of what you'll be doing is adding type annotations to your existing code, to your Python code. And what it looks like is like this. So you'll stick, you'll have some function. It has an argument called numbers, and you'll write in your code that it's a list of integers, and you'll write down the return type as well. And you can also stick a type on a local variable, like this, result equals 0. You can insert a type there. But for the most part, we don't, because looking at that line of code, it's kind of obvious what result is. It's being, it's an integer. It's being assigned a 0. So mostly we omit those, and it works fine. MyPy still has enough information to check that you're doing the right thing, and that the value that you're returning at the end really isn't it. It has all the information it needs. And it's nice because like MyPy is smart enough that for the most part, if MyPy is confused, you would also be confused reading that code. Here's a class. When you have a class in your code, what you can do is you can specify the types of all the attributes that are in that. Pretty straightforward. And if you have a global variable, you can specify the type of that too. Normally, in a case like this one, you don't need to, because like, again, you can see this is a list of strings. But a lot of times, data structures in particular, they start out empty. And so you can see, like in a case like this, it might be handy to say, it's a list of strings as opposed to a list of something else. But actually, so this is the basics. This is what using MyPy is like. You just throw a bunch of stuff in your code. But I feel like it gives a wrong impression. Like, you may think you understood what you just saw, but I'm not sure that it's clear exactly what's going on here. So I just want to make one thing perfectly clear before we move on, which is what annotations actually do when you run your program. So here's some code to illustrate the point. I've got a function called say hello, and it takes one argument, which is supposed to be a string. And then at the bottom, I'm calling this function wrong. The value that I'm passing to it is not a string, it's an integer. And so what do you think is going to happen when I run this program? Well, it's like this. I run the program, and it doesn't care at all. Like, Python just doesn't care. I can sum up the runtime behavior of type annotations in 4 words. There isn't any, mostly. They have no runtime behavior. Python basically ignores the types when you run your program. Code that has obvious type errors still runs as if the types weren't there. And since this is kind of comforting, Python is still a dynamic type language. And you can add types to an existing project without breaking anything in theory. But you have to understand that like the types are understood by Python, are ignored by Python, but they're understood by a separate tool that checks them for you. And the separate tool that's what MyPy is. All right, and the same thing is true for all the examples that I showed. You have to pip install the thing. Sorry, I put the wrong thing here. It says pip install hello.py. It would be pip install MyPy. And then when you want to check the types in your program, you run it. You run MyPy and then name of your script, and it checks that script and everything it imports. And in this case, it spots that I passed an argument of an incompatible type to this function say hello, and it tells me so. The error, I found that the error messages are, well, maybe they're a little wordy, but they're actionable, and they pinpoint the problems, so it's usable in practice. So let's talk about what it is like to use MyPy. After all, we all kind of like Python because it doesn't have really strict types. So like, what is it going to be like? I will be talking about like the good things and the bad things. And the weird thing is that like it's going to feel like there are a lot of bad things by volume. Let's just hop into it. So for one thing, I showed you this example of a type that was list with some brackets. It was a bunch of slides ago, but like list bracket stir for a list of strings. This is actually a feature of the Python standard library. You just import it from this typing module, which you may never have used before. It's not really super useful unless you're using MyPy. But it contains a bunch of the like standard types, and you can just import them from there and use them in your program. The problem is like, as you start using MyPy on more and more code, you end up using more and more of these, and then like it just like it becomes kind of silly at some point. And actually, in my project, I had a type of my own called optional, so there was a naming conflict. It was super annoying. I haven't yet got to the point of renaming it. I guess I probably should. So this is one of the things that happens. You end up importing the world from this typing module, and that's a little bit annoying. I think Python 3.9 is coming out soon, and it helps a little bit with this because the built-in list type it supports square brackets, and you can use that instead of having to import it. But still, there is still stuff in that typing module that you will need. Circular dependencies. I had, and I don't know if you guys have this. Bill, maybe you can tell me if this is like common for you, but like I have modules that import each other, and I was kind of doing it a lot. Is that like?
Yes, for sure.
Yeah. Okay. So I mean, it's not something you really even think about because Python mostly just copes with it, right?
Yes, it
like
did.
I don't worry about it all the
more
time.
often when I had Flask. When I was doing Flask, I did this a lot accidentally, for sure.
Yeah. Yeah, so I would accidentally do that, and then there's a problem where like where this works fine for everything except type annotations, because like for the most part, Python doesn't need for things to be in a certain order, so it's okay for one thing to import another thing and have circular dependencies that way. But it was a pain with typing, and there are workarounds that I'm not going to get into here, but it was a bit of a pain. It made me refactor my code in a way to not have circular dependencies, which is kind of good, but it made me do it, which was annoying. There's a thing that I do. So like maybe this is just me, but a lot of times if I have a function that takes an argument and I think that the argument might be any iterable or it might be a list, I'll often do this thing where the first line of the function will be, foo equals convert foo to a list. Does it even make sense to you, Bill? Like, is it clear what I'm talking about? Maybe nobody does this but me.
No, I do that. Yeah.
Oh, okay, cool. All right. So, because like if somebody's passing in a list, I don't want to change their list. Also, like if they pass in something that's not quite a list, like a generator or something, I just want to like. I may need a list for something. I might need to random.shuffle it or like sort it or something like that. And this makes a copy for that too. The problem is it doesn't work with MyPy. And it's so annoying because like it's annoying because it's a principle that makes a ton of sense once you hear it. MyPy wants every variable to have one type, like throughout. Like it should just have the same type all the time. And that makes sense, but then like if you have an argument that's iterable and you want to turn it into a list, the most natural way to write that just doesn't work at all. So you have to write you have to rename one of them. You have to rename either the argument or the local variable. It's kind of annoying. So again, okay, all right. Like the theme here is I feel a little anxious about these problems because these problems are my problems. And I don't know. Maybe everybody is just better at using Python than me. But the typing module has something called a union. And a union is when, and this happens a ton in Python, when a variable, it might actually be 3 or 4 different types. And you just want to like, you're not going to break that out into 4 different variables. You just want to specify that the type could be any one of 4 different things. And this happens to me a lot when I have JSON-like data, where like it starts out and it's always a list of strings. And then a week later, I'm like, oh, you know what would be helpful is if the thing could be either a string or an object, right? And then it can be two different things. And then I end up using different kinds of objects, and it ends up being like 4 different things. So unions are helpful for that, but the problem is like this is actual code from my project where like I don't know, it just evolved in a really, really silly way to where it got to be like that an object in this collection could be like 9 different things, and that it becomes unmanageable. And I was working with existing code, so there's not much I could do about it without like rewriting the code. I guess again, like MyPy is not doing something bad here. It's just pointing out how bad my code is, which is super annoying. So we have these problems, blah, 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 massive units. If you can use like classes instead, then that goes away, because instead of having a massive union, you just write, you just use the name of the base class and everything's fine. Maybe it's not clear what this thing is. I am writing out a type alias, right? I'm saying, okay, whenever I use the type element, that means the type is either string or an optional or a literal or these other things, right? And it's exactly the function that a base class ought to have if I had written this code correctly in the first place, which I didn't. Okay, another problem with adding MyPy to an existing project is that it touches like every line of code. So you will end up creating conflicts for the people you're working with. And I don't see any way around it. You just have to like coordinate and find a good time to do it, or they're going to suffer. Yeah. Oh, NT in that code stands for non-terminal, and it's something specific to my app. So it's not anything from MyPy or from the typing library. Good question. Sorry, like I knew that was not going to be clear. I should have put some more example code or something, or like a better, less real world example. Okay, there's so there's something called optional in MyPy in the typing library that you can specify, just like you can specify something as a list of strings or a set of strings. You can say something is an optional string, which means it's either a string or none. And I found out that in parts of my program, a particular attribute was optional, and then later it gets filled in, and it's always filled in from that point forward in the program. Well, MyPy doesn't really have this concept of types evolving as your program runs. It's just like type systems don't really do that. So, yep. I could have done that, yeah, that's actually a good point. So yeah, you can do that. You can. There's a thing called new type built into the typing library. Actually, I'm not sure if that would have worked for my particular case. But it's a pretty good idea anyway. And I think that the reason it might actually solve the problem. The reason I didn't do it is because I actually wanted to be told when I was doing something with a value that assumed that it's a particular type, assumed it's an NT, or assumed it's a string, without having checked the other types. So I really did kind of want MyPy to be picky about it. That's part of what I was trying to accomplish here, is like really nail down whenever I have anything like slightly off in my code. It was something that I decided to do because I felt like the code base was kind of getting away from me. This is a 10,000 line code base that just kind of grew over time and was never properly architected, never properly designed. It's also like rocket science what this code is trying to do, which is just like another layer of badness. Yeah. Let's see. Right. Oh, right. So I was talking about optional values. Yeah, when they become non-optional later, what happens is if the annotation says it's optional, MyPy will flag you every single time you try to use it, saying, wait a minute, it might be none. You might get a type error here. What are you doing? Like, you need to check for none. Of course, then if you do actually check for none every place in your program, everybody who looks at the code will be confused. They'll be like, wait a minute, it can't be none here, right? So there's this mismatch between what you know and what MyPy knows, and sending the right signal to MyPy might send the wrong signals to your colleagues. So it's kind of bad. I didn't find a really good answer to this one. And just generally, when you use a type system, sometimes there are puzzles. This happens to me in every language that I use. Like, every once in a while, there's a puzzle. The good news is in MyPy, there's also something called the any type. It's the type of code that you haven't typed yet, and you can use it. You can say, oh, the type of this variable is any, and we'll talk a little bit more about that later. So another problem that I had is I wasn't sure how strict to make MyPy, and this is, it's a good problem to have. It's a good problem that MyPy is flexible enough, but just generally, MyPy, the default is that it doesn't type check any code unless it sees type annotations in it. And if, for example, you have a variable without a type annotation, or an argument without a type annotation, or a method without one, it just assumes that it's the any type. It just assumes that, and it takes a totally blasé attitude towards all your code using that method or using that variable. Which means you can have type errors that don't get noticed just because you forgot to stick a type annotation on the thing. And then MyPy has these special comments that you can stick into your code to say, hey, MyPy, if I'm trying if I'm defining a method without giving it types, I want you to flag me. If I'm calling a method call that isn't fully typed, I want you to flag me. And you just, you have to decide how strict you're going to be on your project. And that means it's kind of a policy choice, and that means you have to talk with your friends on your team and come to a decision, which is like, sometimes I just wish I could blame the tool for its strictness. But MyPy is super flexible, so I have to actually talk with people and come to a consensus on what to do, which is actually a good problem to have. But it is something you have to deal with. Okay, so that's enough about the annoyances. I want to talk about some neat things about MyPy, just to give you a better picture of what using it is actually like. So the first thing is, not all types are like stir and int. Those are the easy ones. Stir, int, none. But you'll spend all your time actually dealing with generic types, data, and data that comes in different forms, like lists, dictionaries, and tuples. Tuples are actually weird in Python because they have two totally different uses. Often you'll use a tuple for a pair of two different things, like a tuple of an int and a stir, and then you write it like that. But also sometimes you use a tuple just as a frozen list, and it looks like this instead. It's a little weird. I didn't have any problems with it. Like as soon as I learned it, it was fine. But I just had to go digging through the docs to figure it out. Right? It wasn't immediately obvious. You actually use these dots. You actually use 3 dots, an ellipsis thing, in your Python code to tell Python this is a tuple of any number of values. All of them are items. All of them are the same type. Yeah. And of course, there's the optional type, like the thing that it's either a thing or it's none. A weird thing about this, there are these things that are not quite obvious, which is like if you have an argument in a function and you say it's one type, but then you specify a default value for that argument that is none, then MyPy silently considers that to be an optional MyType instead of just a MyType, which is a little weird, but it is definitely what you meant. So I guess that's okay. Another thing is when you collect args, you have like all of the rest of the args collected into a tuple at the end. You don't actually write out tuple. You have to write out the type that it expects, or you have to write out what type of extra argument you're expecting, and then it assumes that it's a tuple. So just a gotcha, I guess. Oh, and I had trouble finding out how to write out the type. It is a file. Like I opened a file. Here's the file. It turns out they're built into the typing module. There's one called text.io and one called binary.io, and they work great. Again, once you find them. But it was just funny. Like it's like these are like little things that you don't think about ever when you're writing Python code without types. Like you're just like, oh, I typed open. I opened a file. It's a file. Like I don't have to think about that. I know where to look in the documentation for it. I don't even know what type that thing is. It's just like something in that IO module. I never have to think about it. But because you're now talking about types in your Python code, you have to be able to talk about all these things. So what are some ways that you end up making your code base, adapting your code base to be friendlier with MyPy, right? Because this is kind of this is kind of the heart of the interaction with MyPy. Like, sure, you put in a bunch of type annotations, but the reason you use a tool is its impact on you and your code base. So what does it actually look like to like evolve your code to be a little bit better with MyPy? So the first thing is I showed you the type alias called element. You'll be using those in your code. A type alias is just a global variable that is a type. And you might use them, for example, as documentation. Like, for example, if your system uses integers for user IDs, but you could annotate everything to be int. You could just put :int 30,000 places in your program, and nobody would ever know if you're actually talking about an int or if it's a user ID. But you can instead create a type alias called user ID and use that, right, throughout your code. And that, as documentation, that's super handy. Another place where type aliases are useful is when you have just a rather complicated type, like a dictionary that has tuples for keys and blah, blah, blah. You need an abbreviation, and type aliases are good for that. Just the fact that you're writing this stuff out in your program kind of changes the way you think about it. And it gives you a vocabulary that you can use in comments, in doc strings, when talking to your coworkers. I really like it. I really like that MyPy makes it so that types are something you can talk about. It's really handy. There's something called data classes that if you're not using it, I don't know how old this is. This may be like 10 years old by now. Data classes it's a decorator you can put on classes, and it allows you to assign default values to attributes and just a few other like little conveniences, and it's so cool. It basically auto-generates a lot of the magic methods in Python, like the hash method and the EQ method. It auto-generates a constructor for you, so that you don't have to write the boilerplate constructor for every class every single time. And data class is like the one thing that came out of this is I had no idea this existed and was built into the standard library. I knew there were like some things you could pip install that did that, but I had no idea one was built in. It is so handy, so useful. Also, there's another very similar thing called typing.names tuple. If you're like me, you use collections.names tuple like every new project. Like the first thing you do is create a names tuple. Maybe that's a little bit of an exaggeration, but typing.names tuple is the exact same thing, only a little bit better, because it uses class syntax and you can specify the types of the things. Definitely use it. Definitely use it instead of like there's this weird false economy built into names tuples where it feels really easy. It feels really handy. I write out a names tuple and it's one line of code, and I've gotten a lot of stuff done, and I'm like, well, I can take a break now because I got a lot done with that one line of code. But then the instant that you want to do anything like add a method, there's extra work now. You now incur all the work that you saved earlier. And typing.names tuple uses class syntax, and it spreads things out a little better, so it's easier to read. It's just a better names tuple. It's so great. A couple of weirder things. There's some stuff in the dark corners of the typing module, like protocol classes, because Python has duck typing, where like Sometimes you want to let users just pass whatever kind of object they want to, and if it happens to have the right methods, it just kind of works. There are types for that. It gets a little weird. You can just ignore this stuff at first. There's also something called typedict. I don't know if you do this. Again, like maybe I am uniquely bad, but like a lot. Sometimes instead of defining a class, I just pass around a dictionary that happens to have the right keys. Type systems don't like that, but if you must, you can use this typedict weird thing, and MyPy will be able to cope with your stupid dictionaries that you defined instead of using a tuple, a named tuple or a class. Okay, but again, like maybe part of the point of MyPy is that you won't want to do that quite as much. Okay, every type system needs an escape hatch, because sometimes you just know. Sometimes you just know that the value is an int, and you can't convince the type system it's an int, but you just need to like get it done and move on. MyPy, in particular, just because Python's type system was not designed for this, you sometimes just need to tell MyPy that like the value's not none. I just happen to know it can't be none here. So the easiest way to do this is with assertions. If you assert that a particular variable is a particular type, MyPy notices. Like you've told MyPy, oh, well, the user's telling me that the type is this. I'm going to trust the user, and I'm going to assume that is the correct type. And of course, it tells Python to assert, right? So Python will check it. But it is disabled in -O mode. So like depending on how you run your code, it is possible for you to just be wrong. Like you could put an assertion in your code. Your assertion could actually just be wrong, and your code runs and you hit a type error. But that's kind of true whenever you use one of these escape hatches. Like whenever you just escape from the type system and tell MyPy don't worry about it, you could end up, like the consequence is you could end up with a type error at runtime, which is the whole point is to try to avoid that. Okay, so another thing is you can cast something from one type to another. Like you can say this is kind of like assert instance, but it's a method that asserts to MyPy that the value has the one type. It just tells MyPy, no, I know what I'm doing. Assume that this value is this type. The word cast comes from other programming languages. If that's not familiar to you, don't worry about it. It's a dumb, like made up word. It means treat the value as this type, even though you're not actually changing its type or converting it. There's no conversion behavior here. Just like I happen to know this value is the right type. Python, of course, Python does nothing with this. Python just like it calls an empty method and it just returns the value. You can use a special comment. Oh, I should have put a space here. This is like my other tool, Flake 8, is going to complain that I have a comment without a space. But if you have a comment that says type : ignore, it tells MyPy, hey, don't worry. Like I know there's a type error on this line, but it's not a real problem. I just happen to know the types work out. Everything on this line is fine. And Python, of course, ignores comments. And then there's typing.any, which is the special like any type. It tells MyPy to assume using this value is just fine. Don't type check anything. And again, Python ignores this. I guess this slide doesn't convey why you end up needing these things all the time. But when you're working with existing code, what you'll find out is that nobody was thinking about the type, so they wrote this code. Nobody was thinking about static typing when they wrote this like Python code in this dynamic language. And so your code is doing lots of weird things, like at least my code was. So you will end up, if you're converting existing code, you'll end up using this stuff from time to time. So bottom line, should you do this on your existing project? I don't know. Like I don't know. Like it was an investment, and for me, in my particular case, it did not find like a bunch of. I was expecting it to find some bugs. Like normally, if you take a code base that hasn't been examined and you point some automated tool at it, it's going to find things. It found little things. didn't find anything really significant that was going to be a problem for us later on. And weirdly, like our linter, like that did catch little things where like we actually had undefined variables and stuff, like just straight up bugs in our code. MyPy did find some bugs in debug code, and this is gonna work for you too, where it'll find bugs in your rarely used code, your support code, your like your scripting and stuff around the edges, the stuff that tends not to get tested, or not very well. But actually, like the main benefit was in it focuses us away from documenting the type of everything in English words, because it gives you a way to just say, oh, that's an int, that's a string, done. And you don't have to write it out in your doc string, right? And it refocuses your doc string on the meaning, like on what this function is actually trying to do. And that's just really beneficial. I care a lot about documentation. Maybe not everybody does. But any time that some aspect of the system is self-documenting, and then I can spend my words on stuff that matters and is not obvious, that seems all good. So like I said, there's a investment here. It takes time. It took me like a week to get through, and I didn't annotate everything. I just annotated some modules. You can do one at a time, which is neat. And MyPy just kind of like naturally type checks everything you have put types on and doesn't type check the rest. So you can work incrementally, but it is like, every day that you spend writing types is a day that you're not doing anything else. And in fact, because I had to insert assertions in some places, and like I said, change one local variable into two local variables sometimes when it was two different types, you are actually changing your code when you do that, right? So there's a chance you could actually break something by adopting this like static type checker that's supposed to make things more reliable. But then, yeah, right. So like all of this is like, yeah, I don't know, iffy. I'm glad we did it, because I learned so much about it's cool tech, and I'm like I learned a lot doing it, and I did learn a lot about our code base by doing it, because it does kind of make you crawl over every line of the code base in a way that you don't do very often. In addition, I learned some stuff about Python, like data classes alone were worth that was just fantastic and worth my time. Typing out name table was worth it. And documenting like the disaster that was our code base, just by adding types to everything, so that I can look up at the top of the function if I need to know what the argument set is. That is super valuable. We could have done it by writing doc strings, but MyPy was a really good way to do that in our case. I want to leave you with one example. We had in our code base a graph. It's like I don't know how to describe this, but you think of like a graph as being like any chart that has like little circles and arrows pointing from one circle to another. Like it's a map of the relationships between things. And there's a type called edge that is an arrow. And I found out by doing this that we actually have a really common pattern in our code where we pass around lists of edges because it represents a path through that graph. And I was able to like factor that out, give it a name, write some documentation to it, and now dozens of methods in our code base take a path as an argument instead of being this like mysterious thing that's just like a data structure that you don't understand. And I could document its invariance and talk about it better. So like that, that is worth it. Like that, having that is valuable to us. That's just all I got. Thanks for hanging out, and I want to hear your thoughts about MyPy. So let's open this up to questions. Anybody, Bill?
So one of the questions that came up during the talk that I'm actually super interested in was from Melly Muse. It said, so isn't part of the point of using Python that it's not strongly typed? Why would you use it?
Yeah. Right. Yeah, no, this is I mean, it's definitely true. Like one of the reasons you use Python is that you can just get in and go, and you don't have to worry about the types. And that is one reason that I chose Python for this project in particular, is because Python is super flexible with data, and I knew I was going to be munging a lot of strange data, dictionaries full of lists of strings. And I wanted that flexibility. And I knew I was going to be evolving the data. Like over months, I was going to be evolving it to contain new, strange types of things. And I wanted that flexibility. But I mean, every project goes through phases, and as a project matures, it's more important to have a handle on things. And so that was kind of valuable to me. Python is going to remain a dynamic type language. This isn't going to like take over the world. And Python itself, again, ignores the types. Python doesn't care. Like you can just have types in your program that are just wrong, and Python doesn't care. It just keeps going. So this isn't going to like take away the easiness, the ease of like hopping in that Python has. It's not going to take away the things you love about Python. And again, you get to decide how strict to be. But at the same time, I think that there's I hesitate to say this, it's going to be controversial. I think there is a growing consensus in software generally that having at least an optional type system is really handy. And there are certainly, I'm not adept at using MyPy yet, and I'm not good enough with it that I could like use it only for some things and not for others. It feels a little bit like an all or nothing per module decision to me. But I really appreciate the fact that I get to choose. Like I get to choose what boundaries where am I going to use MyPy? Where am I not going to use it? I that's an extra amount of flexibility. It's not it's not a straitjacket the way type systems are in some languages. It does have escape hatches, and you can just have an entire module of just totally untyped code if you want to. This is up to you. Something I wanted to look at, I didn't get to look at before this talk, is TypeScript, which is like a similar system. There's a whole family of languages called gradually typed languages. That like this is their thing, right? They let you type a part of the system and have an untyped part of the system, and you can pass values back and forth, and it's just no problem. So like it's a growing thing. I think more languages are going to have it. And I'm impressed with this. This is something Guido van Rossum and people working with him made, and it all hangs together really well, and it fits well with the Python language. It hangs together better than I thought it would. It's such a weird thing to have a totally separate on the side type checker for Python. Like what? It does hang together a lot better than I thought it would.
Jason,
I know it doesn't answer the question. There's no answer. Go ahead.
No, there's really, I mean, there is really no answer. I think the best piece of that is that it is optional, right? Like the reason you use this is because it is optional. It provides you some level of safety, right? Potentially, not necessarily safety, but it provides you some sort of like warm blanket that like, hey, if I'm passing these types around, it's one of the things you miss from a type language, right? Maybe ? Yeah. One of the things that I do miss from my like old life potentially as like a Java developer is things like interfaces. And you mentioned protocol something or other. I forget what exactly the slide was, but one of the things I miss from my Java days is some amount of type safety in interfaces. Does this sort of bridge the gap a little bit? Where do you feel like because it's optional and you can apply it where you sort of want to? Does this provide you some level of comfort or safety in that regard?
Oh no, sorry, I didn't. That wasn't happening on my screen, so I guess sorry about that.
That's great.
Well,
That's
I guess I could let the general chat know we're not going anywhere just yet. We'll take questions. I just switched to this screen.
That's good.
Cool.
So
okay,
anyway,
cool.
my question again was, one of the things I miss sometimes when I'm like deep in Python is around missing like some of the type safety that interfaces, the flexibility, but also the type safety that interfaces provide. Does this sort of bridge the gap a little bit between the like total flexibility that Python gives you, but also provide you a little bit of interface comfort?
Yeah, so the way interfaces work here, as far as I know, is you use them as base classes. You write out your interface in Python with, you just have every method raise a not implemented error. And there's also a decorator for abstract methods or something. I can never remember the details. I didn't have any to use it in my project. But yeah, no, yes, like and when you do that, if you specify the types in the interface, like that's actually really helpful because there's no method body to help you out. Like if you're just like reading that code, trying to find out what these methods are supposed to be, the types actually really help. They're really handy. And MyPy also checks that when you override those methods in a subclass, that you're actually doing it right, and that your subclass methods actually match the types on the interface. Which is like, I mean, that's exactly what Java would do, right? So I don't think it's kind of like, oh, well, common sense, but yeah, I mean, like it works. Yeah.
No, that's cool. That's exactly, I mean, that's the kind of thing that I'm sort of interested in. Weston was asking, are the type annotations easily accessible at runtime?
Accessible at runtime?
At runtime, yeah.
Let's see. So they are accessible at. I don't use them at runtime, so I don't know, and I also don't know if that's the best way to use them. And the reason is it depends on what your use case is. Like if you're just trying to generate good documentation, yeah, you can definitely access them as strings. It's just like the dot underscore annotations underscore method. Like there's a hidden attribute on every class, every function that has those. And I think it's I think the inspect module or some other standard module also has a way to just like query and get that information in a more convenient way.
Yeah, there's a comment in chat that inspect get full arg spec is a function that gets you the information you're looking for. Okay,
cool. Thanks.
Yeah.
Yeah. So it's there. It exists, but it's also, I mean, like if your code is written in a kind of nice, if your code is not terrible like my code, then all of that, like every class is at the top level of a module, and all the functions are basically visible. But I tend to write nested functions that are like nested inside of methods and just used in that one method. And then that stuff only exists when you actually call that method. You know what I mean? So there's no way to ask Python for type information about a nested function that doesn't exist because you haven't called the method yet, right? So doing it actually at runtime is, you just won't see some things, right? You won't see the types of local variables. There's no way to ask Python about a local variable that doesn't, of a function you're not running. So there are limits, but for just like classes and methods, that stuff, it works. It will work. Yeah.
Yeah, I think, and I might be wrong here. I've never actually used it, but somehow my recollection is that there are libraries out there, like I think API Star. I think that's the name of it. API Star. I think it's by the same person who did Django REST framework, who has it's sort of a micro framework Flask-like thing that I think uses type annotations at runtime to help define sort of, to help do things like validation for types and that kind of stuff.
That totally makes sense. Yeah.
Which is super neat. Yeah.
Yeah, if you're going to use it to like generate like serialization code or stand up an API based on the type information alone, without that. I mean that would totally. There's definitely enough type information available at runtime that you can do that. I think it is meant for that.
Yeah, I mean, and I know. Well, I think I know. Maybe I'm wrong. I thought that at least early on, the part of the reason for type annotations was for stuff like IDEs, like PyCharm or something like that, to be able to give more more complete type information, to kind of help them out for doing stuff like being able to navigate types, identify errors early on and that kind of stuff, which is not runtime. That's a totally different thing. But I know I think that was part of the original spec.
I haven't used it that way, so I don't know. But yeah, that makes sense.
Melly was also asking, is the advantage to help debug or to protect your code after it's largely locked in? Can you say more about the path that you mentioned?
I mean, to me, the one big advantage is that like it reveals something about this code that was previously undocumented. I had just like, I don't know how else I would have found this, right? Like I just, that's like magic. Debugging, not so much, but it does have the function. I had a slide that I cut that said this. It does have the function that type systems have in like Java, where if you do something really dumb, you just like misspell the name of the variable or something like that, it will detect that. If you just pass the arguments in the wrong order or the wrong number of arguments, it will stop you, right? Like MyPy will just say like, no, you can't do that. Whereas, in Python, you maybe would have run the whole program and it would fall over at runtime. But, this also speaks to the earlier question about like, isn't the whole point of Python that it's dynamic types? Like, well, different code is different, right? Like some code you want to be really careful with. Some code is, more, it's more important to get it done quickly and get moving. And so, I mean, of course the language should be flexible and let you decide those trade-offs yourself. It's not so much for debugging. It does kind of prevent you from having certain kinds of bugs, but to me, the advantage is being able to. I like that my types can be documented.
Yeah. Do you think it's more? Is it tougher? I think the answer is probably absolutely yes. Is it tougher trying to apply types once the code is sort of solidified, or is it more useful potentially to try to apply them and use MyPy sort of earlier in the life cycle of the project, where
it's so much easier. It would have been so much easier if we were using it from the beginning. Yeah.
Do you feel like go ahead. Sorry, I'm sorry.
Go ahead.
I was gonna say, do you feel like
no? My code would have been so much better too.
Right? Yeah. Does it save you from yourself a little bit? I guess is the question. Is sort of the question. Right?
No. I'm like, I am apparently exactly the type of person that just can't be trusted to use Python's dynamic language features responsibly. Like you saw that union with all the, like, I don't know, this thing is a string sometimes, or else it's like 7 different types of objects, right? And like some of those are named tuples, and some of them are like they're just unrelated, and it's bad, right? Like I should have known better. I should have just made a base class from the beginning, and then all those there'd be like 7, subclasses, and it would have been beautiful. But apparently I'm not that good. And MyPy, if MyPy had been around to shame me from day one, I think I would have gone ahead and converted that the way I should have earlier.
Yeah, in some ways, I think that flexibility is both the blessing and the curse of Python, right? Like,
Yeah.
MyPy is sort of coming into this a little bit later, but like the fact that you can return 19 different types from a function is in some ways awesome, and in other ways, especially when you are sort of backtracking into it and trying to apply like some semblance of order to all of this and saying, okay, I want to make sure that I'm only returning one of these 19 types, and I'm not adding a 20th to it.
Right.
Yeah. I don't know where I'm going with this necessarily, but it's both the superpower and also potentially the problem with Python in some ways. So
yeah. No, like I'm totally there with you. Like, and I got like a lot of people my age. I spent the 90s arguing with the Java people and the C++ people, saying, no, Python's so much better. You can do the same work in half the code, and you don't have to ever use types. And like it's like, and I still feel that way, and I still use Python daily, and I don't automatically use types. I don't automatically turn to MyPy from the beginning, especially for throwaway code. Like I want a little. I just want to compute. I just want to add some numbers or something, right? Like who needs it? But I do just feel like different code is different. Sometimes it's useful to have it there.
Yeah. If you're, I'm curious, if you're doing greenfield development, are you pulling in MyPy, or are you not?
Yeah, I am going to.
You are going to. Interesting. Okay.
Especially if I'm using a library that has annotations. I don't know. I haven't really looked. I don't know what packages out there have them and what don't. Maybe nothing has it yet. It's still kind of new. Like the stuff that I found is there are new features in Python 3.7 that you really want. There are new features in Python 3.9 that you really want. Like and so it may be that not everybody's doing this yet, but in general, I would say yes. I probably would, just because I think it helps communicate, and that is too important. It helps the code communicate to other people on the team what's going on. Yeah.
No, I think that makes total sense. I'm sort of similarly curious. Like, if your legacy code base, right? It exists. It has no types. Similar to legacy code base with very little unit tests. Are you, when you're coming back to it, right, and you're trying to figure out what's going on, or you need to upgrade it or whatever, are you applying types? Are you gunning for like 100% sort of type annotation as you're sort of working through all of this, or are you gunning for like selective where it matters kind of type annotation?
Yeah, much more on the latter side. This experience was, you could probably tell, it was an experience. It was very medium. It was like, wow, this was like, for me personally, it was great. I learned something, but for the project, it was very medium for me to spend a week doing that. And I don't, it all depends. It just depends so much, but like, I don't think I would necessarily immediately go to type for like legacy code that I suddenly had to maintain. It might be better to immediately reach for tests. And it might be an easier sell for your manager too. Like, hey, I actually need to sit down and write tests for this thing is a lot easier than, hey, I need to install a brand new tool and like spend a bunch of time making changes to the code base that don't affect its actual work and like what it is actually doing. Tests is a lot easier to sell probably.
Yeah, no, I mean, I think that's.
Well, I shouldn't say that. What I mean is, like, tests might actually be the right move here, not types. Just depends on your code base.
No, I think that's fair. I guess I hadn't considered that as the question. or hadn't considered that as an explicit question of if you had to pick, would you pick tests or types? I don't know.
No.
I suppose I don't know
But
where
yeah.
I would fall down on that. I would probably pick tests over types. But
Gotta be tests.
yeah, I think.
But you
yeah,
want both,
tests,
right? Like, it isn't. You need to choose where you spend your time, and creating either tests or types for a legacy code base, an existing legacy code base, is a big investment. So you may actually have to make that exact choice. And I would choose tests.
Yeah, I mean, I think I would choose tests too. I think if I were doing greenfield stuff, I would also start with types, if only to save me from myself, and help catch places where I'm starting to do like type creep, right? Where I'm adding possible return types. If I'm adding optional to every method I'm writing, like that's probably a smell in some way. So that's super interesting. Yeah, no, it's super cool. I like this. We're sort of slowly adopting MyPy across a lot of legacy code, and it's highlighted some places where we were a little bit less than diligent. I think is the politically correct way of saying that. Sloppy is probably the nicer way of saying it. And I think that's fine. I think that's okay. But
one of the things that I noticed was that sometimes MyPy would find a lot. I didn't think of this when I was making the slides, but sometimes MyPy would flag a ton of errors, and I'd be like, "What on earth is going on?" And I would go and look at the code and stare at it. I'm like, MyPy is right. This code makes no sense. What is going on here? This doesn't even exist. And I would find out, oh, this code is just not being called. It's been dead for a month. They're like, right, like this code isn't being used, so I just delete it. But that's good too, right?
Yeah, no, that's great. Gosh, that's wonderful. I have no problem with that. Did you? I have noticed that there's some people on our team who, as part of this, like, hey, we're going to add types to some of our code, will find themselves like, for lack of a better term, like fighting MyPy in some ways, of being like, and I probably not going to be able to relay this exactly correctly, but like literally fighting MyPy, trying to say like, well, that's not exactly what's going on or whatever. And did you find yourself doing some of that too? Or did you find yourself mostly being like what you just described? That doesn't make any sense. That's not being called anymore. Like, just throw it away.
Wow. Fighting MyPy, that sounds like something that will happen.
Yeah.
Fighting MyPy. Yeah, yes. So that is why I had a slide on escape hatches. And once I was giving the slide, once I was actually reading it, I could tell that like I didn't properly motivate that. But yeah, no, like for some reason it does happen that if you think code is just a little bit weird or quirky, and MyPy just has a really hard time dealing with it, and then you end up fighting MyPy. And you should probably just assert or put a type : ignore in there, or an any, and forget about it. But something about that doesn't sit right with me. Like maybe it's the part of my personality that made me a programmer to begin with. Is this just like I want it to be exactly right. I want it to be complete. And the good news and the bad news is that the type system they've come up for Python, is super flexible, and you probably can say the crazy thing that you need to say for this one line of code. So yeah, I fight probably a phenomenon that you will see, and I don't know what the answer is.
No, I don't think
MyPy poses all these questions. There's a lot of them that I don't know the answer to.
Yeah, MyPy is sort of an existential problem. Yeah. No, I think that's probably correct. Yeah, I mean, I've noticed people doing it, and we have always, at least so far that I'm aware of, found a solution to it, and sometimes that involves some refactoring.
Yeah, cool.
And quite frankly, that refactoring makes a lot of sense. It is sometimes just preceded by a lot of banging your head against the desk trying to understand what's going on, or why MyPy thinks there's a problem when you don't think there is one. Usually it ends up for the better. It's kind of this like, these tools are smarter than I am in some ways, and that's both wonderful and also incredibly frustrating. The bots are smart.
Yeah. Well, like the main way that I ended up fighting MyPy, or like just the main problem that stuck with me that I didn't really know how to deal with, is just sometimes I just know. Sometimes I just know the value is not none. Sometimes I just know that, you know, this thing can't be this value here. And it's not easy to tell. It's not easy to tell MyPy that. You know, you just assert, I guess, and move on. There's not, I don't know. It's, yeah. It's not a tool that like makes me jump up and down with how this. It's just, you know, it's more of a, well, it's useful. We can do stuff with it.
Yeah, it's a tool like any others. It helps sometimes, it doesn't others, and use it when it helps. Avoid it or ignore it when it doesn't. I think that's all we've got. I haven't seen a question in the chat in a little bit, so that may be
cool. All right,
that may be all of it. So
I do look forward to seeing type annotations and documentation more. I really, one of the things that I love about Python is that people write good documentation. People just do. The ecosystem, there's just a culture where people just like will write not just lots of it, but very like carefully written, you know, edited sentences about it, but they still have to tell you what type everything is. They just have to, and that's boring information. And it's better to have a notation for that built into the language. And so, like, I just think it's going to make Python documentation even better. In the long run, if you know, to the extent that it gets adopted. I know it's been slow. It's been like 5 years, but I think it still might be a big deal. I think it might be that this gets to be, you know, a very widely used tool.
No, I think so. I mean, I think we're still very much on the upswing of it. I think I think it has in some ways similar to Python, like the switch to Python 3. Like there's a massive lag to the uptick here, and I think we're just now starting some of that. And I think as more people do it, more tools will be built on it. More stuff will happen automatically as a result of types, and I think that's ultimately a good thing. I don't want to see Python be I don't want Python to turn into Java. I don't think anyone does, but I do think that there's something there, right? I think there's a benefit to types and a comfort that comes with some of them and checking them and that kind of thing. So I think it's great. Jason, I really appreciate you being exceptionally willing to be a guinea pig for sort of a test, and I think this went exceptionally well, and thank you.
Well, I had a great time, Bill. Thanks for helping me work out like the intense technical difficulties that I was having, and thanks everybody for staying around.
Yeah, man. We appreciate the hell out of it, and we will be back next month, probably closer to our regular day and time, which I don't remember off the top of my head, but I think it's May 28th. I don't have my calendar up in front of me, unfortunately. I think it's later in May. I think it's like the 28th, but so we should be back. I don't know off the top of my head exactly what the presentation is next month, but I will notify everybody as soon as I do. So thanks everybody for showing up. Much appreciated. And now we're going to figure it out. So I want feedback. I want to know what works. I want to know what doesn't, so we can make this better.